So if you look underneath this root right here, you've got your 4, your a to the 8th, your b to the 14th, and your c to the 5th. And you are taking the 5th root of all of those. So instead of trying to like focus on all of them at one time, I think it's easier if you will split it up and do the 5th root of each one. So I've got the 5th root of 4, the 5th root of a to the 8th, the 5th root of b to the 14th, and the 5th root of c to the 5th. All right, so then I'm going to do each one of these individually and then take care of them. So 4, that's just 2 times 2, right? So there's not 5 or more of any prime factor. So I'm just going to leave that one alone. I can't do anything with it. But I can split a to the 8th because 8 is bigger than my root of 5. So I'm going to split this one. So what is the biggest number that is smaller than 8 that will divide by 5? That would be 5. And how many a's does that leave left? 3 of them, right? All right, so I have split that one. Now I need to work on b to the 14th. That does not divide by 5, so I'm going to have to split it. So what is the biggest number that is smaller than 14 that will divide by 5? B to the 10th. And that leaves how many b's left over? 4. And then we know that c to the 5th is a perfect 5th root, right? So I'm going to leave it alone because I can take care of that in a second. So now that I have split everything I can split, I want to do the perfect ones first. So a to the 5th, that's a perfect one. B to the 10th, that's a perfect one. And c to the 5th is a perfect one. So do those first. So the 5th root of a to the 5th is a. So I'm going to mark that out because I already took care of that one. The 5th root of b to the 10th is b to the 2nd. I'm going to mark that one out. And then the 5th root of c to the 5th is c. So I've done that one. Now, the rest of them all get multiplied underneath the root. So you have 4 times a to the 3rd times b to the 4th. And now you have fully simplified that. On 25, if I look down here, I have a root in the bottom, but that root isn't fully simplified. So before I do anything, I'm going to fully simplify my root. So I'm going to have to split that. So what is the biggest number smaller than 8 that will divide by 3? 6. So that leaves 2 of these left over. So I'm going to go ahead and take the cubed root of this first one. So the cubed root of y to the 6th would be y to the 2nd. And then I'm left with the cubed root of y to the 2nd. So I don't care that the y squared is in the bottom, but I care that the cubed root of y squared is in the bottom. So I'm going to have to multiply by some cube root so that I get a perfect cube. Well, what do you know about when you multiply variables in a cube root? When I multiply variables, what do I do with their exponents? I add them. So if I want to get a perfect cube, what's the closest number to 2 that is a perfect cube? 3. So if I want this to become 3, that means that this exponent has to be a 1 because I'll add those together. So I'm going to multiply by the cubed root of y on top and bottom. This is kind of like when we made perfect cubes with numbers in the last part of the lesson. So on the top we have x, cubed roots of y, and then on the bottom we have to do a little bit of simplifying. So I have my y squared. What are you going to get when you take the cubed root of y squared times the cubed root of y? you're just going to get y, right? Because this is the cubed root of y to the third, because I have to add these together, right? And then that's going to make a y. And then all I have to do is multiply those two y's together on the bottom. So my top stays the same, and on bottom that's going to give me y to the third. I've now gotten rid of the y, the cube root of y squared that was on the bottom. All right, same thing like we did with the roots a while ago. Keep things together and focus on each little part individually. So like the 14 and the 2. I've got 14 divided by 2 times, and then I have an x on top paired with an x to the 3/4 on the bottom times, and then I have a y on top, but I don't have a y on the bottom, so I'm going to put the y on top, but I'm going to put it over 1 times, and then I don't have a z on the top, but I do have a z on the bottom, so I'll put a 1 over z to the negative 6th. So your goal here is to not have any negative exponents in the end. So once you've simplified, you know you're done when you don't have any negative exponents and everything's all divided out. So 14 divided by 2 is 7. And then when I put these together, they have the same base, so I would take the 1 and subtract the 3/4. So 1 minus 3/4 would be 1/4. There's nothing to do with this y to the 1/3, right? So I just have y to the 1/3. But here I have this negative exponent. Well, if I take 1 and I raise it to any exponent, it comes out to be 1, right? So I could think of this as 1 over z raised to the negative 6th. And how do I make that not negative? I flip this, right? So now I have z to the 6th power. So moral of this story is, if you have a negative exponent in the bottom, all you have to do is move it to the top to change that to a positive. And vice versa. If it is z to the negative 6th on top, I could move it to the bottom and it will become positive. So if you look, you've combined all the x's and all the y's, all the z's. You've simplified everything. You don't have any negative exponents, so you are done. So we're going to do the same thing here. We've got 16 over 8 times, and then x over x to the 2/3 times, there's a y on top but not on bottom, so y to the 1/3. We're going to put that over 1 times, no z's on top, so 1 over z to the negative 4th. So we're just kind of splitting it up and focusing on each part. So 16 divided by 8 is 2. When I divide these x's, I would have to take the 1 minus the 2/3, so this would be x to the 1/3. I can't do anything with the y, so it's just y to the 1/3. And to get rid of this negative exponent on my z, I'm just going to move it to the top, which makes it z to the 4th. I've combined all my x's, my y's, my z's. No negative exponents, so I'm done. All right, so we're going to add a problem in here, 27a. So again, I'm going to just kind of line things up. So I've got 2 over 4, and then we have a over a, b squared over b to the 4th. I've got a c on top, but not on the bottom, so I'll put the c to the negative 2nd over 1. And then no d on top, but I do have a d on the bottom. And then we're going to focus on each one. So 2 over 4, that reduces to a half. So 1 over 2. I'm just going to make one big thing here. And then what happens to your a's here? A divided by a is just 1, so that just goes away. And then we get b to the second divided by b to the fourth, so I have to take the 2 and subtract 4, which gives me -2. When you divide these, you always put the answer in the numerator. But what's going to happen to this b here? It's going to move where? To the bottom, because we want it to be a +2, right? So let's move it to the bottom. Another way for you to look at this is, do you see how you have 2 b's on top and 4 b's on bottom? So these go away and you're left with 2 down here. Okay? Now, will the c to the -2 stay up here? No. We need to move it to the bottom so that we can change it to a +2. And then the d, there's nothing that goes with it up here, right? So it will stay on the bottom. And I don't like that my 1 is way over there. So you have 1 over all of that. We have no negative exponents. We've combined all of our like terms, simplified everything. So we're done with that. All right, when we're adding and subtracting variable expressions, you still think of them as being objects. Like if I had like 5a plus 6a, that would be 11a, right? So you think of the root as being an object. So if you want to add two things together, everything behind that coefficient has to be the same. And you think of it like an object. So like this is like, let's say that the square root of y represents bananas. This is 5 bananas plus 6 bananas. That makes 11 bananas. B-A-N-A-N-A-S. So in number 29, if you look behind your coefficient, you have a cubed root of 2z to the 5th. But over here, behind the 1, you have z, cube roots of 54z squared. I can't put them together because they're not like terms. So what I need to do is, if you notice, this power is bigger than 3, right? So this is not a simplified root. So what you're going to do is, and I would probably separate this into two sides, because I'm going to do this side first and simplify it, and then I'm going to simplify this side, and then we can subtract them, okay? So ignore the 12 for a minute, because you're just going to work with your root here. So I have to take the cubed root of 2. Can I reduce the cubed root of 2? No, because 2 is a prime number, right? And so I can't do anything with that. But the z to the 5th, I can split that up. So I've got the cubed root of something times the cubed root of something. So what is the biggest number that's smaller than 5 that will divide by the 3? 3. And that would leave you with 2 z's, right? So the only thing I have here that is a perfect cube root is this one right here. So if I take the cubed root of z cubed, I get z, and then everything else will go underneath the root. So the 2 and the z squared. But remember, that's this back here, right? I've just rewritten it. So I have to take it times 12. So what's z times 12? 12z. So stick that in front. So you've simplified this side. So your goal over here is to end up with z cube roots of 2z squared at the back here. So 54. If I want to split 54, I'm going to have to do a factor tree, right? So 54, we've got 2 times 27. 27 is 3 times 9. And 9 is 3 times 3. So I have 3 to the 3rd. So there's my perfect cube, right? Times the 2. So I'm splitting this up. I've got the cubed root of 3 cubed times the cubed root of 2. Now, can I split the z to the second? No, because that power is smaller than my root number, right? So it just stays underneath. So the only perfect cube root I have is this one up front. And what are you going to have to multiply that by? This negative z, right? So the cubed root of 3 cubed is 3 times a negative z would be negative 3z. And then underneath the cube root, you have 2z squared. So now, see how you're the same? You have z cube roots of 2z squared and z cube roots of 2z squared. So 12 minus 3 is 9, and then you tack that back on because we're just treating it like an object. We now have 9 of the z cube roots of 2z squared. So I think it's easier if you just focus on one side and then focus on the other side and then combine them. All right, so on this side, I'm going to leave the 16 out here for a second, and I'm going to work on the fourth root of the 3p to the sixth. So 3's prime, I'm not going to be able to do anything with 3. But 6 is bigger than 4, so I know I can split that into two separate roots. So what's the biggest number that's smaller than 6 that will divide by 4? 4, and that would leave me with a p squared. So the only thing that's perfect right here would be the fourth root of p to the fourth. So that would be p. And I'm going to have to multiply that times the 16. We don't want to forget we have that. And then under the root, we have 3 and the p squared. So on this side, we're going to have to do a factor tree for our 48. So we have 2 and 24, 2 and 12, 2 and 6, and 2 and 3. So that gives me 2 to the fourth. There's my perfect fourth, right? And a 3. So I have the fourth root of 2 to the fourth, and then the fourth root of 3. Can I split up my p squared? No, because 2 is smaller than 4. So the only perfect fourth root I have is this 2 right here, correct? And I have to take that times negative p. So that gives me negative 2p, and then fourth root of 3p squared. So now when I look behind my numbers, my coefficients, I have the same thing, right? So 16 minus 2 is 14p times the fourth root of 3p squared. All right, so on this last one, we don't have a number to worry about up front, right? But what is the root number for this? It's a 2 because it's a square root, right? So what do you know about 9? 9's a perfect square, right? So the square root of 9 is 3. And then I need to split up my w to the fifth. So what's the biggest number that's smaller than 5 that will divide by 2? 4. So I do w to the fourth, and that leaves me with w. So if I simplify this, the square root of w to the fourth would be w to the second, and then the square root of w. All right, on this side, 3 is bigger than 2, right? So I'm going to have to split that. What is the biggest number smaller than 3 that divides by 2? 2, which leaves me with 1. So the square root of w squared is w, but I have to take that times negative w, which gives me negative w squared, square roots of w. So I have a w squared, square root of w, same thing over here. 3 minus 1 is 2, W squared, square roots of W.